Hi friends, this is the experiment regarding the figure of merits, and you can see that we have to adjust the spot exactly on a 0 while the focusing of the lamp, that should be focused on the BG, and therefore there is a mirror which is mounted on a coil. The coil is suspended through a silk thread or a non-magnetic material thread or a plastic in between the two permanent magnet. Please do read the construction of the ballistic galvanometer or a mirror galvanometer, so you will get an idea how exactly mirror is mounted. In short, there is a one rectangular coil which is permanently suspended between a two permanent magnet, and that coil is tie up through a thread, and that thread on that thread the mirror is going to be tested or the mounted. So this focus lamp will be focused their beam on the that mirror, and mirror will be reflected to the scale. It is a acceptance or a prerequisite condition that between the mirror galvanometer and this reading scale, the approximated distance, that should be a 1 meter. That means this distance must be a 1 meter. Now I will be changing the polarity or the commutator key, and you can see that the spot is moving from a right hand to the left hand. Let us see that. You have seen that the spot is on the right hand side of the 0, and now it is on the left hand side. While you are performing the experiment, you should be very clear that without potential or without supplying a battery, or you can close the damping key, and in presence of a damping key, the spot must be on the 0. The reflecting spot of the mirror galvanometer must be on the 0, and that is the prerequisite condition or the beginning of the or the pre-setting of the experiment. Thereafter, as shown in the observation table, the variability of the resistance P and resistance Q, that you have to vary in such that so that the summation of the P and Q should remain constant. As for example, P is equal to 1 ohm and Q is equal to 1499, so the summation will be 1500. The second reading will be P is equal to 2 ohm, then Q become 1498, and so on. Such kind of you are required to take some around 7 to 8 reading, and you will be able to find it out the sensitivity of your ballistic galvanometer, that per watt microamps how many millimeter is displaced on the scale. So per giving a unit amps, how many millimeters of the scale displacement is taken place, that would be your sensitivity of the meter. We can check it through either by observation table, or we can check it through by the graph. We will see all this detail in the graphical and the script. This is the resistance R. Okay, let me show you from here the entire setup of your circuit board. Then this is your resistance R, this is resistance P, this is resistance Q, this is potential supply, this is a commutator. Let me take it there so you can visualize the commutator easily. So this is a commutator. It is a 4-way key where this 2 key or you have to plunge it to the another two holes, that is this one. So the plug-in key will be always in the opposite fashion, either this in front of two holes or this in front of two holes. Basically, this four terminal key is known as a commutator. It helps us to change the direction of a current which is passing through the belvestic galvanometer or the mirror galvanometer. This is your Q. Right now I have adjusted 1000, 400, 300, so 1700, 1700 plus 40, 30, 20, so it's 90 and 90. So 17 plus 1800, 1799, and the P is just 1 ohm, and therefore the summation for our present setup is 1800 ohm. Am I clear? Now when I will change this 1 ohm to 2 ohm, so I incremented 1 ohm over here, then naturally I should decremented a 1 ohm in a Q. So what should I do? That the 2 ohm key I will be close by the 1 ohm key, so I reduce a 1 ohm over here, and whereas the resistance of the R should remain constant throughout the setup, throughout the setting of the readings.